Hello student, this is Debabrato Mukherji. I will be teaching you power generation process. In this, the first unit is conventional energy generation methods. In this unit, I will be teaching you thermal power plant, gas power plant, hydro power plant, nuclear power plant in detail. These are the contents. According to contents, we will be proceed in the PPT. First, thermal power plant. What is thermal power plant? Generally, power, thermal, and plant. That is thermal power plant. Thermal heat, power, the electricity which is generated from the power plant, and it is fed to the grid, and the whole system contributed in the plant is situated in the plant. That is thermal power plant. Next, this is general layout of thermal power plant. In this, you can see there is a boiler which is connected to a turbine, which is connected to a coupled to a electric generator. Through boiler, superheated steam hits the turbine, which rotates the turbine, which is coupled to the electrical generator. Though it is, since it is coupled, therefore electric generator will also rotate, and this rotation will result in the production of electricity in three phase. Indian power grid, generally generation or Indian sector or Indian electricity sector or Indian generation sector, generation is always in 11 kV, especially in India. 11 kV it is generated in power plant. Whatever power plant may be, it may be electrical, it may be thermal power plant, hydro power plant, gas power plant, nuclear power plant. All the power plants, it will generate or it will give electricity in 11 kV. Further, it will be step up so that it can be transferred or it can be transmitted in long distance. Step up in form of 230 kV, 400 kV, 132 kV, or 765 kV, whatever be the transmission line requirement. Next, it is a broad classification or broad layout of thermal power plant. In this, you can see in the left side of the screen there are two blocks: coal storage, coal handling, ash storage, ash handling. Coal handling through the in thermal power plant, generally fuel, which is coal is taken as a fuel. In that, it is being crushed, made in pulverized form, so that efficiency or combustion efficiency increases, and it is fed to the boiler furnace where it is burnt. Boiler, there is a water in a boiler which will be heated at a particular temperature. After that, there will be a production of steam which is given to the superheater. Superheater makes the steam moistureless, so that moistureless steam or high pressure steam which will hit the turbine blades, which will make the turbine to rotate. And since the turbine is coupled with the generator, and it will also rotate the electric generator. In the figure, you can see boiler is connected with superheater, then it is connected to a wall and to a turbine, and one upper side you can see economizer. Economizer, what is done, that from the water from the condenser is fed to the economizer, so that heated steam is cooled down, and flue gases is taken out to the chimney, and the water which is again extracted is given to the boiler. I will discuss whole part wise in detail in the following PPT. This is a layout of pressurized fuel plant. There you can see a boiler bunker where pressurized mill is there on the bottom side. Through that it is given to the furnace where heat up is done. Steam drum is there which where the superheater tubes are there. Through those tubes water is flowing and heating is done. Heating combustion of coal is done in the furnace, uh, where the heat of that coal is given to the steam, so that steam is heated in such a way should not be any moisture. From there it is again reheated, that the temperature is again leveled up one step, that is given to the you can say to the turbine, high pressure turbine, low pressure turbine, and it is connected to the generator. From the low pressure turbine, there you can see there is a condenser. When the steam is hit to the turbine, that heat up or the residual steam is given to the condenser, where that steam is condensed in a water form. Then it is again fed to the boiler through a valve and flow, the pipes that generate from pipe, and it is again given to the boiler tank and steam drum. Next, basic operation. See, you can see coal is heat up, boiler tank, there is a water which is boiled in such a way steam is produced. Steam is pressurized steam, the force that causes the turbine to rotate at a very high speed, and that after pushing to the turbine, it is going into the condenser, where the steam is condensed back to its liquid form. The process is repeated and it is fed to the boiler. From coal it is given to from coal electricity is produced. How? This is the block diagram. You can see chemical energy is converted to thermal energy, is converted to kinetic energy, then it is converted to electrical energy. Coal which has chemical energy, that is given to the superheated steam, where thermal energy takes place. Thermal energy is converted to the turbine, where kinetic energy or mechanical energy is there, where from where mechanical energy of the system is given to the generator. The generator converts mechanical energy to the electrical energy. This is our overview of the plant. Later pictorial view. In this you can see that it is written thermal power plant is a power plant in which the prime mover is a stream. Water lifted, turns into the steam, spins a turbine, which drives the electrical generator. After it passes to the steam, after it passes to the turbine, the steam is condensed in a condenser and recycled to where it was heated. This is known as Rankine cycle. Parts. What all parts I have just showed you in the picture, that there is a description over there, some little bit description. I will let you know what are those. First is coal conveyor. There is a conveyor belt is you can say it is a transportation medium from coal end to the boiler end. Okay. That coal from the coal storage, the coal is transported to a conveyor belt, to a pulverized mill, then to a boiler. All conveyor belts is the only transportation medium. Pulverizer, I told you, pulverizer is done in such a, is done because it increases coal combustion efficiency of the coal. Boiler, there is a furnace which is used to create steam by applying heat energy to a water. Superheater, as I told you, it is a plant. It is a part of a power plant where the steam is conditioned by drying the equipment inside the steam drum. Through it is a piped upper drum into a tubes. inside an area of the furnace where it is called as superheater. Generally, steam is dried so that there is no moisture. Why? Because if there is a moisture, little bit moisture drop in the steam, and it is heated to the hit to the turbine blades, then blades of those turbine may get rusted. Therefore, it is said that there should not be any moisture in the steam. Economizer are mechanical devices intended to reduce energy consumption or to perform another useful function like preheating of a fluid. Reheated, it is added or heat is added to the high pressure steam turbine, where it is a mechanical device that extracts thermal energy from the pressurized steam, convert into a rotary motion. That is a kinetic energy which I told you just before. Generator, it is a device which converts mechanical energy to electrical energy. Condenser is used to condense gaseous substance into a liquid state, or gaseous state to the liquid state. The reactor, widely used for the removal of air. Functional diagram, here you can see there is a boiler is there, pulverized mill is there, coal is there. From coal, the conveyor belt, through conveyor belt it is going into the coal hopper, pulverized is being done, then it is fed to the furnace, okay. Then there is a tube, you can see there is a tube which is superheated tube, which makes the steam superheated, moistureless. It is fed to that is steam, high pressure steam is fed to the turbine. Turbine is rotated, or it is coupled. This is coupled is to the generator. When the superheated steam rotates, when the superheated high pressure steam is heated to the turbine, then torque is produced, which makes the turbine rotate. And since it is coupled to the generator, due to coupling, generator will also rotate. And this coupling due to this rotation, there will be a magnetic flux will induce, and hence electricity will produce in 11 kV, which is fed to the transformer. It is a step up in form of, I just told you, 132 kV, go to 32 kV, 400 kV or 765 kV. Then it is given to the electricity grid. This is a condenser. This is a steam condenser. That is steam which is heated to the heated to the turbine. That steam is fed to the condenser, so that in a steam condenser, that steam is gaseous state is converted to a liquid state. That again it is fed to the boiler. Then that few gases will go through a chimney. Stage 1, this is a conveyor belt, this is a pulverized mill, which I have told you this is the only way of transportation from coal handling plants to a pulverized mill to a boiler. Second, you can see coal delivery is done through a roadways or railways. Unloading is done, then outdoor storage, preparation, transfer, covered storage, in plant handling, waiting furnace. Okay. Next, raw coal is taken from a particular coal mining station. It is given through a railway track. Through railway transportation, it is given to the wagon tripler. Wagon tripler is a form of bunker where the coal is handled. From there, it is given to the hopper. Hopper is just this. This is a hopper. See, coal hopper. Coal hopper, from where crusher is being done, then it is given again to the bunker. This all process over here. This is from here to here, or I should say from here to till this part, all the transportation medium is conveyor belt. Conveyor belt is used. Okay, raw coal feeders, then coal mills. Coal mills is a place where pulverization takes place. Then it is given to the boiler furnace. Pictorial view, you can see coal crusher. This is a coal crusher unit where coal is crushed. Then it is given to the vibrating separator. Vibrating separator is because the in Hindi you would call chuda. That part is given to the belt, and solid, that those which have not been crushed properly, it will be separated out. Then it is given to a coal dryer so that there should not be any moisture in the coal. Then it is given to the again belt conveyor. From here rejected part, or those coal which is still moisture, there is a moisture in the coal, then it will be rejected. On the coal which is useful, the pulverized coal which is useful, it is given to the bunker, to the elevator, and again it is given to the coal to the furnace. This is the ash handling plant. Why ash handling plant is used? Because when the coal is burnt, there is ash left. That ash is given to the ash handling or ash pond. Why? Because this ash is sometimes it is generally used for cement plant. These ashes is very useful for cement plant for their production purpose. This economizer ESP, electrostatic precipitator. Why it is electrostatic precipitator? Because in electrostatic precipitator there is a rod, charging rods are there, which helps all the charges to all the flue gases which has some parts, those crushing parts or small molecules will stuck in those rods, and the gases which is left will be given to the flue gases. This you see fly ash through ash plant. Also there will be a it will be given to the cement plant, and through those fly ash it will also given to the cement plant. Those two things from generally these ashes are very useful for cement factory. Stage 2. This is a stage 2 part where the pulverized coal is burnt. Water from the feed pump is preheated in the boiler. That pulverized coal is burnt in such a way the combustion of efficiency of that combustion coal is increased. Pulverized coal increases the combustion efficiency. Boiler C. DM water, that is demineralized water. What is demineralized plant? Demineralized plant, every power plant has, generally every thermal power plant has demineralized water plant, because we do not use river water directly, or from the river water it is not directly pumped to the boiler tank. It is demineralized. All the unwanted molecules is all the unwanted molecules which is not which is harmful for the boiler tank, which can makes the boiler rust. Those particles are filter out in the demineralized plant. See, that water is through the water tube, it is given to the boiler furnace, boiler tank. This is a boiler furnace. Air from the environment through induced draft fan, it is forced air is given to the boiler furnace, and pulverized coal from the end, from the bottom end, it is injected in the boiler furnace. This is the part. superheated is from this. When the water is boiled up, there is a steam generated. That steam is given to the superheated steam, superheated part, or through that superheated tube. It is given to the superheated tube, and it is given to the with high pressure. It is given to the turbine blades, heated to the turbine blades. See, front view how it looks. But if I want to see how the furnace looks like from the front view, it will look like this, but at the top view it will look like this. Boiler, same thing, air, fuel, air. Again, same the flow of steam, how it takes place from boiler drum, boiler tube, superheated, then turbine, condenser, then flow water pump, fluid water pump is there, where demineralized water is also given over here. Then it is again given to the economizer, from there again boiler drum. Steam turbine principle is that the steam is caused to fall the pressure in passage of nozzle. Due to this fall in pressure, certain amount converted. Impulse turbine. Impulse turbine is this is the passage of steam through moving part of a turbine in such a manner that the pressure of the outlet of the blade is equal to the inlet inside. That means inlet and outlet pressure is same in impulse turbine. Okay. In impulse reaction turbine, the drops in pressure suffered by the steam its flow through the blades and adds through blades, and it is again given to the condenser. This is a stage 3 part. This is a you can see this is a superheated tubes. This is a superheated tubes. Over here, heating is being done on these tubes so that the steam in this superheater is maintained in such a way that steam, there should not be any motion in the steam turbine. This is the pictorial view of the turbine, how the turbine blades looks like. Turbine, superheater, high pressure turbine, and intermediate turbine, intermediate pressure turbine, low pressure turbine. There are 3 steps. See over here, high pressure, intermediate, and low pressure. High pressure in this superheated steam directly fed. In the intermediate, the output of the HPT is reheated and used to rotate IPT, that is intermediate pressure turbine, and exhausted steam from the IPT is directly fed to the rotate the shaft of the IPT, and that steam, that exhausted steam, is given to the condenser. It is a front view. You can see high pressure, intermediate, and low pressure. This is the economizer part. You can see there is a tube outlet of feed water outlet and feed water inlet. Okay. Economizer, I am focusing on each and every part in detail. Kindly look up to it. You can do it very concentratedly. See, this is a boiler economizer. Okay. And from this boiler, feed water inlet is given and outlet is here. What does generally economizer do? That steam, which is exhausted steam. Exhausted steam is given to the economizer so that it is the temperature is cooled down, gaseous state is converted to liquid state, and the gas which is left, it is flowed to the chimney, and the water which is which is liquid stage, which is converted, is again fed to the boiler. Flue gases coming out of the boiler carry a lot of heat. An economizer extracts a part of this heat from flue gas and use it for heating liquid water. The use of economizer is saving coal consumption also. It also uh, saves the coal consumption, and efficiency of the boiler is also increased because heated water is again given to the boiler. Air preheater. Air preheater may be of three types. Generally, after flue gases leave economizer, some further heat can be extracted from them and used to incoming heat. And cooling of flue gases may by 20 degrees centigrade increase the plant efficiency by 1%. Reheater is also a steam boiler in which heat is added to this high pressure steam, which has given up some of its energy in expansion through the intermediate pressure turbine. The steam after reheating is used to rotate the second steam turbine, where heat is converted to mechanical energy. This mechanical energy is used to run the generator, which is coupled with the turbine, thereby generating electrical energy. Feed water advantage: improves the overall efficiency. It removes the dissolved oxygen and carbon dioxide, which sometimes otherwise cause boiler corrosion, which I told you, and why demineralize also used. Thermal stress due to cold water entering the boiler drums are avoided. Quantity of steam produced by the boiler is increased. Some other impurities carried out by the steam condensed, and due to corrosion of boiler and condenser are precipitated outside the boiler. Separator. See, this is a part of the separator and reheater. There is a tube separator. Separator is a component of steam engine in which steam, after it has left the boiler drum, is heated above its saturation temperature. Stage 6. This is a turbine generator, consists of series turbine connected with each other and a generator on a common shaft. So, turbine, high pressure, low pressure, intermediate pressure, low pressure, then coupling medium, then generator, where magnetic field is produced, through which electricity is generated. Production mechanism: same thing. Through coal it is given to the furnace, boiler furnace, steam, then it is given to the high pressure steam to the turbine, generator, then transformer, then to a transmission line. Generally, thermal power plant is situated somewhere near the river. It is expected that you should plant a thermal power plant near a river, because we need lot of water, and the river can only provide that water. Generator. Synchronous generator is used, and generally voltage of 11 kV to up to 20 kV, but in India it is 11 kV. Okay. Step 7. This is a condenser part, which I've told you. Exhausted steam is condensed, or gases part is converted to a water. Condenser, same thing. This is again a same thing. Step 9 is that enormous pressure of steam pushing against a series of giant turbine blades turn the turbine shaft. The turbine shaft is connected to a shaft of the generator, where magnet spins within the wire to produce electricity. Electricity is sent to the power grid, then travel to the substation located in the town. What is the advantage? Due to coal is easily available, and if it is used properly, there are a lot of advantage. but there are also disadvantages. Since it is a non-renewable, fast depleting, coal dust, or that coal dust is very harmful. Thermal power plant from the chimney of the thermal power plant is, according to the standard, it is required that from the chimney there should be some standardized gas should only pass out, so that pollution does not occur in a hazard way. If the last point I should read out, mining of coal leads to irreversible damage to the adjoining environment. Coal mining is very, you see in different parts of the country there are a lot of states where coal mining is done, but the places near those coal mining area is very it creates a lot of damage to those adjoining cities. Now I should conclude. Boiler, what should be the temperature? There should be 600 plus degree temperature and 15 megapascal steam should be produced, and high pressure turbine at least 350 degree Celsius steam should hit the turbine, and with a pressure of 7 MPa. Reheat, that steam re-enters the boiler should be reheated, and in intermediate pressure turbine the temperature should be 600 degrees Celsius, 600 degrees Celsius more than, and the pressure should be more than 67 MPa. Then LP turbine, again low pressure turbine, the temperature should be 350 but pressure will be 900 kPa. In condenser, the temperature of the temperature goes down, it will be 40 degrees Celsius, and the pressure will also go down 10 kPa. Generator, which is coupled with the turbine, and it will produce three-phase power. See, this is the review of the thermal power plant system review. You can see, you can read out. There are 8 points. Cooling towers. What does cooling tower? Why you use cooling towers? Because in condenser, when the exhausted gas is or gaseous is converted to the liquid state, there is a lot of gas which has very high temperature. It should be cooled down and fed to the released to the air. There are generally 3 ways, but we use closed system through water cooling or air cooling. We can do where we can cool up or we can bring down the temperature of the gas. This is the pictorial view. See, this is in the left hand side, that system is shown here, and on the right hand side the actual cooling tower is in this way. Now the conclusion: in a block diagram way, chemical energy is converted to heat energy, then it is fed to the turbine where mechanical energy is produced. From that mechanical energy it is fed to the generator where mechanical energy is converted to the electrical energy. Then steam is given to the through the nozzle to the given to the from the generator, the 3-phase generator is given to the grid, but from the turbine part the high pressure steam is nozzled with a nozzle speed. It is given to the condenser where the exhaust steam is or exhaust gas is converted to the liquid part. Again it is given to the pump, through tubes, through valves, through pipelines, it is again fed to the boiler. Thank you.